So we'll do a couple more problems related to partial fractions, and then we'll even have one more other video that's going to deal with some more complicated problems. And I encourage you, now that you've seen kind of the introduction, to see if you can set these problems up yourself. So let's say we had x plus 1 divided by 6x plus x squared dx, and you wanted to find this antiderivative. Just pause and see what you can do, and then come back. So first thing we'd want to do is say, you know what, I think x plus 1 divided by 6 times x plus, what am I doing? This doesn't make any sense, right? X plus 1 divided by x times 6 plus x, right? That's factoring my denominator. I want it to be equal to a over x plus b over x plus 6, right? So I'm basically breaking it up, partial fraction decomposition, because I know how to anti-differentiate these two. Multiplying by the least common denominator, which is x times 6x plus x, I should get x plus 1 equals a times x plus 6 plus bx. It's a really important step, and it's an algebraic one. Now I need to set the coefficients of x equal and the constants equal. So there's ax and bx makes a plus bx plus a times 6. So I need a plus b to equal 1 and 6a to equal 1. So 6a equals 1, then a equals 1/6. And if 1/6 plus b equals 1, then b equals 5/6. So I've just found a and b, and I can now rewrite my integral as the integral of 1/6 times 6 times 1 over x dx, that's a over x, plus 5/6 times the antiderivative of 1 over x plus 6 dx. And that's simply 1/6 ln absolute x plus 5/6 ln absolute x plus 6 plus c. Now I could probably use some properties to combine those two, but I'll just leave my answer like that for now. So again, factored the denominator, wrote two separate fractions with unknown constants a and b, multiplied by the least common denominator to make my equation more simple, wrote it as something times x plus a constant so that I can see that a plus b needs to equal 1 and 1 needs to equal 6a, and then solve for a and b, and then integrated. Great. Again, try this example, and then pause the video, try the example, and then come back and see if you got it right. So 20 over 25 minus x squared dx. So first, I'm going to write this in factored form as 20 over 5 minus x times 5 plus x. And that I want to be equal to a over 5 minus x plus b over 5 plus x. Multiplying by the least common denominator, I should get 20 equals a times 5 plus x plus b times 5 minus x. And hopefully you're starting to recognize the pattern of this denominator is always gone, so you're just going to get 20. And then you're going to have a times 5 plus x, which is what it's missing, and b times 5 minus x, which is what it's missing. And this is going to then tell me that 0x plus 20, right, because remember I technically have a 0x there, is equal to 5 times a plus a times x plus 5 times b minus b times x. So 0x plus 20 equals a minus b times x plus 5a plus 5b. So I need this to equal that and that to equal that. That means I need a minus b to equal 0, and I need 20 to equal 5a plus 5b. But if a minus b equals 0, then a equals b. So 20 is equal to 10a, and 2 is equal to a. So b is equal to 2 as well. So this integral is now equal to the integral of 2 over 5 minus x dx plus 2 over 5 plus x dx. And that's simply 2 natural log absolute 5 minus x plus 2 natural log absolute 5 plus x plus c, which is 2 times ln of 5 minus x times 5 plus x, because I'm using the product property. And I could even square and say it's ln of 5 minus x times 5 plus x in absolute value squared plus c, and that would be my answer there. So the next video we'll go over a couple problems that are actually more complicated, but these should give you kind of a basic idea of the problems that we're hoping you can solve.